Hello, everyone. This is my day 2 from home. We're going to, hopefully, yesterday when you did the inverse trig functions, that wasn't too painful. Today, we're going to have another day of trig functions. Just like I talked about on Friday, we're going to hit trig functions quite a bit, which means they're probably going to be pretty important for the test. So we're having another day of basically trig functions. So without further ado, I'm going to share my screen and we shall begin. Okay, so today we're going to be looking at angles of elevation and depression. So yes, we're dealing more with trig functions, but really it's only going to be one bit of new material, 2 definitions. These 2 definitions we're about to talk about are going to be the only bits of new material. Then we're going to apply them to the trig functions. So an angle of depression is the angle formed by a horizontal line and a line of sight to a point below the line. So if we're looking at like this pilot right here, if he's looking down at the control tower, he's looking down. That's depression. Remember, I feel like this is maybe a bad metaphor, but when you're depressed, you're feeling down. So depression, you're going down. Or if you've been to the doctor, they get those tongue depressors to put in, like that popsicle stick. It's called a tongue depressor. The doctor takes it and pushes your tongue down. An angle of elevation is the angle formed by a horizontal line and a line of sight to a point above the line. Elevated, that's the key here. An elevator takes you, in most cases, up. You know, most, what goes up must come down. Well, yeah, but you think of an elevator, it takes you up. So looking at our picture here, angle 1 is an angle of elevation because the control tower is looking up at the plane. The thing to remember is always go from the dotted line to the solid. I'm going to put that as a note. Go from dotted to solid. So if you're looking from the dotted line to the solid line, which direction are you going? If you're going up, it's elevation. If you're going down, it's depression. So let's look at this first example. They want us to classify each angle as an angle of elevation or depression. So A, ask us about angle 3. Here's angle 3 right here. Remember, we go from dotted to solid. So for that angle, I'm going down. Which one goes down? Depression. So angle 3 is an angle of depression. And then we have angle 6. You go from dotted to solid, dotted to solid. This one you're going up. dotted to solids going up. So this is an angle of elevation. Then they ask us about angle 4. So angle 4, dotted to solid. That one goes up. So this would be an angle of, we're going up, it's an angle of elevation. And then angle 5. So angle 5, you're going from dotted to solid. It's going down. That means this is an angle of depression. That's really all the new material today. We're going to be now just applying it to problems where you have to use trig ratios. So John Paul, who is Tommy's older cousin, Tommy Joe's older cousin, works part-time as an air traffic controller at the Angelina County Airport, which is abbreviated as LFK. Actually, it's KLFK, but we'll just say LFK. He sights a plane at an angle of elevation of 41 degrees. Mary Beth, the pilot, reports the plane's altitude is 4,000 feet. What is the horizontal distance between the plane and the airport? Round to the nearest foot. Okay, so this basically now, yes, they give us a word problem, but once you get your picture drawn, it goes back to what we've done in the past. So they want the horizontal distance. There we go. So then what's next? Label your legs. And then you circle the angle given. So this 4,000 out here, how is it positioned in relation to the angle? It's opposite. And then the side we want, the X, it's adjacent. So if we think back to SOHCAHTOA, which one uses opposite and adjacent? Tangent. So I'm going to have the tangent of 41 equals 4,000 over X. And now I just need to solve. So multiply by X on both sides. Those cancel. You get X times the tangent of 41 equals 4,000. Divide by the tangent of 41. Those cancel. We get X equals 4,000 over the tangent of 41. At this point, we can type it in the calculator. So remember, your calculator needs to be in what kind of mode? Degree mode. So I check mine and I see mine is in degree mode, so I'm good. Remember, if it's not, you can just take your cursor and click it and change it. So I changed it out of the mode I need it. So if yours says radians, just take your mouse and click it, and it'll change it to degrees. We're going to do 4,000 divided by the tangent of 41. Remember, to get tangent, you hit the trig button. That's right there beside the 7. And it asks us to do this to the nearest foot. That's going to be the nearest whole number. So 4,601 feet. That's how far Mary Beth is from the airport, horizontally. 4,601 feet. Okay, on to the next example. While racing Tommy Joe to the top of a 90-foot fire tower during a hike in the Angelina National Forest, Daisy Mae spots a forest fire. Oh no! The angle of depression to the fire is 7 degrees. What's the horizontal distance between the tower and the fire? Okay, so the angle of depression, remember that's dotted to solid, so they're looking down. It's a 7-degree angle looking downwards to the fire. Now, if that's 7 degrees, that also means that this little bitty angle right here is 7 degrees. So hang on here. So this little bitty angle right there, 7 degrees. Okay, so now here's our triangle. We can proceed like normal. So label your legs. Circle the angle that's given. Now, how are the legs positioned to the angle that's given? Well, the 90 feet, that one's all the way across from it. So this is going to be opposite. The X is next to our angle, so it's adjacent. So if we remember our trig ratios. So Katoa. Which one deals with opposite and adjacent? Tangent. So we'll set up tangent of 7 degrees equals 90 over x. Multiply by x on both sides. So the x times the tangent of 7 equals 90. Divide by the tangent of 7. Let's cancel. We get x equals 90 divided by the tangent of 7. So let's type that in. 90 divided by the tangent of 7. And it says, doesn't it say round to the nearest foot? It does. So we want the nearest whole number. 733. So they're going to be 733 feet from the fire. Okay. So now let's just kind of do some review. So this first problem is like what we did on Friday. We're not going to touch trig. We're using the trig ratios, but we're not putting like sine or cosine in our calculator at all. Do not touch trig on these next four. So it wants to put it as a fraction and as a decimal. A asks us about the cosine of B. So I'm going to be standing at angle B. Now, what two sides do I need for cosine? I need the adjacent over the hypotenuse. So if I'm standing at B, which leg, which we didn't label those yet, label your legs. Which leg is adjacent to B? That's going to be this 5 right here. We are adjacent right here to B. So we're going to have 5 over, which one's the hypotenuse? It's going to be this 13 out here. This is our hypotenuse. Always and forever, 13 will be the hypotenuse here. So 5 over 13. Now they want that as a decimal. Again, we're not going to hit trig. There's no trig to do here. We just did the trig. We found the ratio. We just want to do 5 divided by 13. And then I'm going to hit Control Enter because I want a decimal. To the nearest hundredth, that's 2 decimal places. It's going to be 0.38. Okay, B, ask us about the tangent of A. So for tangent, what do we need? We need opposite over adjacent. So now I'm not at B anymore. I'm going to be down here at A. I swam from B down to A now. So which side is opposite of A? I'll look across, that would be the 5. It's opposite of A. This is going to be 5 over. Which one's adjacent to A? Don't tell me 13. 13 is our hypotenuse. 12. 12 is adjacent to A. So 5 over 12. You can turn that into a decimal. So 5 divided by 12. 0.42. Okay, so now, well, now we're going to go back to B. We're back at B now. We want to get the sine of angle B. So what do we need for sine? We need opposite over hypotenuse. So which leg is opposite of angle B? Give me this 12. So we're going to have 12 over Which one's the hypotenuse? 13. 12 over 13. Turn that into a fraction. 12 divided by 13. Or turn that, sorry, it is a fraction. Turn it into a decimal. It'd be 0.92. And then the last part, cosine of A. So that's going to be adjacent over hypotenuse. So we go back to A. Yeah, which one did we already pretty much identified everything we can here. So which one did we write down as adjacent to A? The 12. And the hypotenuse is 13. So 12 over 13 is your fraction, which means 0.92 is your decimal. And we didn't have to touch trig on any of these. No, the 4 we just did. Okay, next one. Use your calculator to find the trig ratios. So now we do want to touch trig. This is just straight up calculator work. It says tangent of 35. So trig, tangent, 35. It wants to round to the nearest hundredth. That's 2 decimal places. It's going to be 0.70. Then they ask us for the sine of 14. It's going to be 0.24. And they ask us for the cosine of 78. .21. Okay, there's those 3. The next 3. We're doing the trig inverse to find the angle measures. So remember the inverse, that's the one with the -1 on it. So tangent inverse of 0.25 to the nearest degree, that would be 14 degrees. Then we want the sine inverse of 2/5. It's going to be to the nearest degree, 24. And then the cosine inverse of 0.53. To the nearest degree, that would be 58 degrees. Okay, so for this next one, they want us to find the unknown angle measures to the nearest degree. So we're finding angle measures. This would be trig inverse. So here we're doing the inverses. Excuse me. Okay, first one, they ask about angle A. So angle A is right here. You can pick any 2 sides you want, as long as you use the right ratio. So I'm going to do, let's see, what do I want to do? I want to do 15 and and 25. So here's our legs out here. 15 is which leg to angle A? It's going to be our adjacent leg. 25 is the hypotenuse. So which one of our trig ratios uses adjacent and hypotenuse? That would be cosine. So I want to do the cosine inverse of the adjacent over the hypotenuse. You get 53 degrees. So angle A is 53 degrees. That's what we just found. This is 53 degrees. This box means angle B is 90 degrees. So how can we get angle C? Well, we could use another trig ratio, or we could use the fact that we could add the 90 and the 53 together and then subtract from 180. It's going to give you 143. Subtract that from 180. That's going to get you 37 degrees. Now, let's say you wanted to use the trig ratios. You wanted to do trig on this last one. And let's say you still wanted to use 15 and 25. Well, for C, 15, we're over here at C now, that wouldn't be adjacent, that would be opposite. So we could do the sine inverse of 15 over 25. See that, sine inverse 15 divided by 25. 36.8 or 37 degrees, which is the same thing as we got right there. So either way works. If you're kind of rusty on your trig, then you may want to use just where you add. It's like, okay, I got through one, let me just add it to 90 and subtract from 180, and I'm done. But that's totally up to you. Okay, so there's the notes for today. Stay tuned for the guided practice.